Since we have talked about data challenges, now let's talk about model challenges. Let's go through them one by one. Let's first discuss what overfit means. As you can see in the diagram, we have lot of training data points, right? And you can see that ML model maps each of the points accurately. But do you think there is a pattern? Is it able to find any pattern here? No, right? It is just trying to find a model which can map to each point. For example, let's understand in terms of human. Suppose you have a book in Russian language and you don't know how to speak it. Okay. Now, suppose you memorize this entire book. Now, if someone asks you some content from it, you might be able to answer, even though you don't understand it. Why? Because you have memorized it entirely. So you will be able to answer it. But as soon as they reframe their question by asking a different meaning, by changing the wording, you won't be able to answer. Why? Because you don't know Russian language. You don't understand what it is, right? Same way, what happens in overfitting is we don't find the pattern. Rather than finding the pattern, we work on just memorizing the training set, that it should work on it no matter what. Even though we can see that pattern should be something like this in the data set. But here, we don't care about pattern at all. We are just mapping the training points, right? So this is overfitting. As you can see in the above image also, overfitting basically means that in your training model, you will see 99% accuracy or even 100% accuracy. But as soon as you move it to production and you feed it new data, your accuracy will drop to 10 to 15% or maybe 20-25, but it will basically drop a lot. Why? Because you're not finding any pattern. What you are doing is you're just trying to map ML model on your points. Another example could be that suppose a person has a dog. Okay. Now, by default, they will have this mindset that, okay, all dogs are like this. All dogs are same. They are very cute. They are very sweet. But that's not always true, right? There are also wild dogs also who can bite you. But that person has limited information about complete dogs. Why? Because they have not seen those kind of dogs. So in ML model, you can see these kind of cases. When you have less data, for example, something like this. As you can see, we have a very less data here, right? And because of this, when you're trying to implement a model on it, you're getting something like this. Zigzag pattern. This is not actually a pattern, but since your model has to get a low error scenario, it will map your training points like this. But if you get more data, it will actually find a pattern and it will resolve in the second diagram. What you can see in the second diagram, something like this. So sometimes when you have overfitting, the problem could be that you have a very less data. That's why your model is not able to train properly on it. So one way to resolve it is get more data. But there are also cases, as you can see in this diagram, where you have lot of data. In this diagram, where you have lot of data, but still it's not finding pattern. It's basically zigzag, right? Why? Because your model is too complex. So another resolution which you need to do is simplify your ML model. So it's very easy to identify whether your model is overfitting or not. If you're able to see, okay, on my training data set, I can see a 99% accuracy or 100% accuracy, but on production data set or my test set, I'm not able to see any good accuracy. It's 15%, 20%, 30%. Then you know your model is overfit and you have to do one of these things. Now, second scenario is underfitting. As you can see from this diagram, underfitting means that your model is way too simplified. It is not able to, also this is not able to find the pattern as well. If it's something is able to find the pattern, that means a good model. So, but as you can see, even on the training set, you have these dots already given to you. This is training set, but still your model is performing very poorly even on the training set itself. You can see there is a straight line, but there is a lot of points which are too far away from it, right? That means this model doesn't even perform good on training set. If you find this kind of model will have accuracy about 15%, 20%, 15 to 30%, let's say. That's a very poor accuracy, right? So underfit means that only. Underfit means that your training dataset accuracy is itself low. So if your training the accuracy is about 15-30% or less than that, that means you know your model is performing very poorly in training dataset. If I have to give one of the examples, let's say it is like this. Suppose whenever I have any kind of issues, my parents would say the same thing: wake up early. If I say I don't get hungry, they will say wake up early. If they say I'm not able to study, they will say wake up early. If I say I'm not able to perform good at sports, they will say wake up early. Not getting good marks, wake up early. Same thing every time. Why? Because it's a very simplified model. They're not able to understand the pattern. They're not able to understand the complexities. It's a very simple scenario where where your model is very simple and the effect on your data is very less. So how to resolve them? So what do you think the issues were there in this underfit model and how we can resolve them? One of the very common issues which I can think of is that you need to have a better model. By better, I mean complex model. So let me just erase it. So what do we need is we need a complex model. If we had a complex model, something like this, as you can see in good, then there were high chances that we would be able to find a pattern, right? So that's how we will resolve underfitting. There are also sometimes when you will not be able to find any relation between features and their output. For example, let's say there was a housing price table and we also have its output. Now let's say it has owner name and let's say it also has age of owner, let's say. But both of these data are not relevant to housing price, right? So that is also sometimes the reason when your model is underfitting. That means it is not able to find any pattern. So another solution which you could do is you can find better features. Now, with respect to both underfitting and overfitting, there is also one another thing which you can do. As you can see in both of these places, in underfitting, what we have to do is we have to increase the complexity of a model to match the pattern to find the pattern. Whereas in overfitting, we have to decrease the complexity of our model, right? So we have something in ML which can do both of these and we can control it based on our demand. So that is known as regularization. Let's say you have a graph, okay, and it's higher degree polynomial. So graph would be something like this, okay. But now let's suppose that you multiply this x4 and with this and this x3 by a very small number. Let's say you multiply it by 0.001. Then what would happen? These value will become close to 0. And rather than 4-degree polynomial, it will become second degree polynomial. So graph would be simplified something like this, right? So that is what regularization does. It decreases the importance of few features. So what happens? Generally, when you have a feature table, something like this, by features, I mean owner favorite color, zip code, number of bedrooms. These all are features, okay? But not all features have the same weightage in the housing price, right? For example, if I have to give a random guess, I would say that square footage has the maximum impact on sale price. After that, maybe area will also have the maximum impact on sale price, right? Then number of bedrooms, the least owner favorite color. So as you can see, each feature has its own importance. So what regularization does is it decreases the impact of few features. That means the features which are not that relevant, it will automatically decrease their value such that your model is able to find a better pattern, and it will simplify from something like this to simplify something like that. That's the use of regularization. We'll discuss the math behind it and how it is does in later section. So you can fix underfitting and overfitting by controlling this regularization parameter. If you want to make your complex model to a simple model, what you will do, you will decrease the regularization and vice versa for underfitting. This will be more clear in the sections when we'll cover this in real life projects. So don't worry if you don't understand it. But let's move ahead on testing and validation. Testing. So how do you generally test whether your ML model is working or not working? It's very simple actually. Whatever training data set you have, what you do is you train your model only on 80% of the data set. And for 20% remaining, we use it as a test set. So what happens? We'll train our ML model on this 80% data set. And after that, we'll check on this 20% how much our ML model is performing with when new data is there. Like how good is the accuracy? Is the accuracy poor or not? Whatever error you get on this test set is also known as generalization error. What this means is when new data is coming up, how good your model is performing. Like what is accuracy? It's still 80%, 20% or what? So this is how we test and validate. But there's another thing. We talked about regularization also, right? But regularization value you don't know. Your ML model. So how will you know that whether we need to decrease it, whether you need to increase it? Of course, you know that by overfitting or underfitting. If we know that our ML model is performing very good on training set, but very poor on test set, we know that it's an overfitting problem. That means we know that our regularization parameter needs to be decreased, right? So if it's overfitting, we know that we need to decrease it. But by how much? By 1, by 0.1, by 0.100, by 100, how much? Now, one way you could do is that you can train on multiple values. Let's say 1, 10, 100,000. Maybe you decrease it by this amount and you kept on trying for like 100 models. Let's say these are total 100 values. And you check, you trained your data set on these values. Okay. After that, what you did is on your test set, which was your remaining 20%, you validate each of this model that how much accuracy is there. And what you did is you found, okay, this one has only 20% accuracy. So you increase it again to make it 40%. Then you increase it again to make it 100%. Same way you raised it out. Okay. But the drawback of this is there is still possibility then when you launch it in production, your model still fails. Why? Because now you have also used your test data in your ML model learning. How? Because this parameter, which is also used in your ML model learning, is now calculated by test set. Now how much it is failing or not failing. So there is still possibility then when new data comes up, things go wrong. So to resolve this, we divide our data set into three parts. The first is known as training set, which will be used to train our model. Second would be test set. And third would be validation set. Depending on the data set, you can choose a percentage, but generally this is 70 to 80%, 70 to 80%. And these are like 10 to 20%, both of them. Now, after training your ML model and finalizing a model on the test set, that what would be the value of regularization parameter. Now you will pick that on validation set, whether it works fine or not fine, to know whether it will work with good accuracy on new dataset or not. So this is how you will do testing and validation for ML models. I'm sure there are a lot of open questions that how to resolve them properly, how to code for them, how to fix them. But I don't want to cover a lot of theory or a lot of maths in this class. It's much better if we do them when we are working on a project, which we will do from next class.